So it's great to be back here. I presented at FinDEVr last year, and it was a lot of fun getting to meet with a lot of interesting and really smart people, getting to talk about what we do, which is application security, which is a very lonesome and very, very rough thing to talk about. And I see faces nodding, which is true. My job is to make this palatable, and especially since this is the last presentation, I tried to inject some humor in here, so I went kind of crazy on the GIFs. Hope you don't mind midway through the presentation. So a little bit about what we are and what we do as a company. We're about 4 years old, and we're focused predominantly on protecting applications and databases at runtime. And this is a big difference compared to the way applications and databases have been protected for the last, I would say, decade or so, which has been predominantly served by firewalls or perimeter-based defenses. When we think about something like application security, we've been focused on either vulnerability scanning or perimeter-based defenses. We've taken a completely different approach with a brand new methodology, and I'm actually going to show that to you in a little bit when we go to a demonstration. But our primary verticals are around banking, financial services, and e-commerce. 4 of the 5 largest e-commerce companies in North America, many of the largest banks and financial services as well. So we're growing very, very quickly in just a span of a few years, and I think that's ultimately due to the fact that we're taking this different methodology and this different approach. So 3 use cases to just get right out of the way before we jump into the current state of things is where people typically use us. The first is this idea of having security baked in from the very beginning when you're building your application, rather than treating that as an add-on. The second, and we'll get to this point, which is the secure software development lifecycle, what's predominantly known as the SSDLC, and the idea of how can you augment the SSDLC to make it more efficient. So you spend less time ping-ponging between QA, security, and development teams to release a secure application. And then finally, around making incident response more tactical and more efficient. We're actually going to touch on all of that when we get into a demo of the technology in just a few minutes. So I'll start by going into where we are as an industry, how we got here in the last 10, 15 or so years. First topic is that AppSec is actually really, really challenging, and development and operations teams make it a lot more difficult from a security perspective. The first is that computation as we know it has significantly changed. We're moving away from traditional data centers and we're going to the cloud. We're going away from traditional environments to running in microservices, VMs, containers, and we're breaking down these large monoliths into smaller services, and we're composing our larger applications with services or microservices. And I have a fun thing about DevOps in a little bit. But there's 4 realities I want to touch on. The first reality is that you've heard of firewalls, and the truth is that firewalls don't really have the application context when it comes to making a good decision. And the truth is that it doesn't really scale with DevOps. So a good example being something like this. The idea is that you can have a bad actor disguising itself as a good actor and simply going past a firewall-based defense system. And this is primarily due to reality number 2, which is that defenses that rely on signatures or past definitions are always going to lose. I saw this firsthand. I had to build up security and development teams at places like MySpace. Who remembers MySpace, the social network that time forgot, right? So that's what I had to do over there. So between that, the BBC Worldwide, News Corp, a bunch of other organizations. And the big challenge was, how do you scale a security program that's based on signatures and defenses? And it's really, really hard, and you're ultimately going to lose. So let's take some gibberish like this. This is a regular expression that's designed to protect against cross-site scripting attacks. Now, I have absolutely no idea what this thing does, and I've been writing regexes for years. But presumably, a regular expression like this should be able to catch against something like that. Simple JavaScript alert hello, which is just going to create a pop-up. But the problem is I can disguise this, and I can turn it into that. This is the same exact thing. In fact, this is built with an open source tool called JJ Encode. It's freely available. You can go online. You can type in any arbitrary amount of JavaScript, and you generate this garbage on the other side. And the reality is that I can disguise my payload as many ways as I want. I can obfuscate it as many ways as I want. And I can do this infinitely. And it becomes a different kind of complex challenge for organizations to try and protect against. And this is where a lot of firewall and firewall-based defenses that rely on patterns typically fall down. The third reality and I touched on this before, is around vulnerability management and vulnerability assessments. It takes a lot of time and costs so much money to try and fix a simple vulnerability. This number here, 150 days, is based around a SQL injection. So think about that. A SQL injection that's going to exfiltrate sensitive information takes 150 days for your average large organization to go and close that out. I didn't believe it at first, but it makes sense because it has to come from production, go through a QA process to validate it, vet it, make sure it's not a false positive, goes through development, back through QA, making sure that the security team see it, and you do this churn over and over again. Now, what makes this harder is this thing called DevOps. So the idea of DevOps is really straightforward, the idea of continuous integration, continuous deployment. We want to move fast, right? That's the point. The point is we want to be able to push things out faster to production. The business wants to get a win. In reality, this is what it is. Right? This is exactly what it is from a security person's perspective. OK, dev, OK, ops, you want to deploy whatever you want to deploy to production. You want to move fast. No problem. Go for it. Where does security fit in? The truth is, today, security really doesn't fit into this thing called DevOps, but it's happening. And security needs to find a way into the process. And that doesn't mean scanning your code every single time there's a build. Sure, that's good hygiene, but there's got to be a better way so security can be part of the DevOps process and not some sort of force that's coming after the process of deploying some artifact to a production environment. The fourth reality is that applications lack logging and visibility when it comes to critical issues. I've seen this firsthand. I've had to do a lot of root cause analysis, or RCAs. And I'm sure some of you have too. When there's a security issue, it's a pain in the butt to go back in and figure out exactly what happened. You're doing all sorts of crazy log correlation, event management. You're dealing with things called SIMs. You're dealing with independent log stores, trying to figure out exactly what happened. And it feels like you're kind of almost like Quentin Tarantino trying to piece the whole thing together in a weird narrative that may or may not actually make sense. And so what typically happens is when there's a vulnerability, this is your SOC. Your SOC has no idea what's going on. They're freaking out. And their first clue is, well, something's going on with the application. Let's call the app developers, and let's figure out where the application logs are. They don't know. They probably didn't even write the logs, right? And that's the truth. And that's exactly where we are today as an industry when it comes to security logging and security visibility. Security operations centers, they need those logs. But application developers, application engineers, they're not thinking about that when they're building and designing their features. So we need something better. And you can probably guess where this is going. And the idea is, what if an application could protect itself from attacks? So there's vulnerabilities, which is looking at vulnerable source code, how to improve source code. But then there are attacks. And attacks are taking advantage of vulnerabilities in the applications or weaknesses in the application. Some of you may have already heard about the Struts 2 vulnerability that happened over the last couple of weeks. It affects a lot of Java applications, predominantly because of an issue in an XML parser in Java. Effectively, this parser was actually executing the exceptions message. So someone could put in code into the exceptions message, and it would parse and execute, remote code execution. And it's not only going to affect Struts 2, it's going to affect a lot of different Java projects. And we're probably going to see that not only over the coming months, but the coming years. So the idea is, what if the app can protect itself from attacks? And that's why we built Prevoty. The idea is really straightforward. Without relying and forcing your engineers or application development teams to change their source code, what if you could bring an agent to the application or a plugin to the application that could inject security in the application, and specifically at the runtime? And the idea is it will work great with legacy applications or third-party applications where you don't even get access to the source code. But it also works really well with modern applications where you're constantly in this exception management process. Now, we designed this thing to be working in polyglot environments from the very beginning. So it supports a wide array of platforms, a wide array of languages, so from strongly typed and previously closed source languages like Java, .NET, all the way down to weakly typed and open source languages like Ruby, Python, et cetera, supporting different kinds of databases, and with all the information going out into large SIMs and log stores. Now, I talked about DevOps before, and it's important to mention where we see our story with DevOps. The idea is that, look, security wants to be part of the process, but it's unreasonable to think that we can scan these large, giant applications, because scanning code can take hours and hours and hours to do. And the idea of DevOps is to deploy as fast as you can to a production environment. So the idea is, what if you could have this continuous monitoring and continuous protection capability that gets deployed with the application to a production environment? And that's where we see our customers using us. Again, not only in legacy applications, but in modern applications. And not only in big data centers, but also in cloud environments as well. The idea is to have this artifact, a secured artifact, go wherever the application is going to be deployed. So the last piece I'm going to touch on before we get into a very quick demo is the idea of actionable analytics. The neat thing is about being within the application is that you can package insights across a really interesting chain. So you don't have to be sort of looking at it just from the network, kind of like a firewall does. By being inside the application, you can pull out things like the line number of where is a database query executed, the query itself, the database that it was talking to, the user that was logged into the application. Forget the IP address. You actually know the user that was logged into the application. So if you're trying to figure out who kicked off that SQLi or who was affected by the reflected cross-site scripting attack, you actually have that information now. And so previously you had to do this giant correlation across different products, different pieces of infrastructure. The idea is by being inside the application where something actually executes, you can take that payload and you can look at that and you can give that to security operations teams, development teams, security teams, and they should be able to quickly build a narrative just based on one log event, exactly what happened. So really briefly, I'm just going to show you a real-world demo of the technology in a sample Java application. So hopefully the demo gods are on our side. This is a Java application composed in Java 8 using AngularJS in the front end, and using a REST-based service in the back end, querying a MySQL database. So this is fake data, so don't think that I think Apple stock is down. I think we scared a couple of people in our demos. So don't run and think you lost your portfolio. You're probably just fine. So if we search for something like Google, you get back Google's data. If you search for Apple, you get back Apple's data. So this is kind of how the interface works. But if you're an attacker and you try to do something cheesy like this, script alert 1, you see this pop-up. So I've got JavaScript execution. Now, without going fully into it, what's happening is there's interpolation based on the result coming back from the server back in the DOM, and that's firing off this JavaScript. And attackers can use this to steal all sorts of information, redirect you to bad websites. Some pretty nasty things can happen. Now, a more trivial example, but one that's pretty scary, is this. So some of you may have seen this before, the idea of terminating a quote and introducing a 1 = 1 in here. And this is basically using a tautology, a statement of truth, to try and exfiltrate information. But a tautology doesn't have to be that simple, and exfiltration can look more advanced. So I'm just going to copy pasta this giant query I wrote beforehand. And in this case, I'm able to pull out all sorts of sensitive information from the other side. Now, as an app team, I may not have any visibility around this because I didn't plan for logging any security events like this. And I'm using AngularJS, which already has built-in sandbox protection in the front end, but I'm evading that protection. So we may be thinking that a lot of the client-side controls are keeping us safe, but in reality, they really aren't. And there's trivial ways that you can evade it, as you've seen already. So I'm just going to go back into the console here, and I'm going to go in, and I'm going to install Prevoty. That's it. And I'm going to rerun the application. So this idea of DevOps and being able to embed directly in the application, that's that. So specifically, I'm using a chef script to go in and get Prevoty attached into the environment. And now we're going to start the application back up. And so we'll wake the application up. I'm just going to restart the interface, make sure everything is starting up correctly. But the idea is that we're an agent. We're attached to the runtime, which means that we get to see all sorts of interesting behaviors happening from within the application. So if we were to go back in and just verify that the application is behaving as expected, Google is still Google. Apple is still Apple. And now if we go in and we try script alert 1, that pop-up that fired before isn't happening. And if we were to go back in and try that or 1 = 1 attack, that tautology, we prevented that as well. And in this demo, I just have the exception being blasted up to the front page. In practice, you never want that. You want to show the attacker a blank screen, make them think that what they did actually worked. And if we try this payload again, we prevented that one as well. And so I didn't have to change any bit of my source code to make any of this stuff happen. I'll close the demo off just by simply showing you kind of the intelligence that we're able to output and where all that goes. So I've been dropping all these events and all this intelligence out to log files. And you could view this in any SIM or log management store. It doesn't matter if it's Splunk, ArcSight, QRadar, Elasticsearch, Hadoop. We have customers that use all of those. Some of them use actually all of those solutions in their environment to view this data. So I'm just going to quickly jump over to Splunk just to give you an example of what our dashboard looks like, how you can jump in. You could look at and visualize any of these payloads. But if I wanted to just jump in here specifically to a single payload that's around a database access violation, I'm going to open this up. You can start to see things like who the user was based on an IP address, the kind of issue that actually happened, the query itself, the URL where this actual attack happened from, who was logged in, so you've got the session information, the cookie metadata. And what's really cool is if I just jump down to the stack trace, we've got a full stack trace of execution. So in this case, you can see search servlet.java line 157. If I jump back into here, I'm now going to go in and search for search servlet.java. I'm going to jump to line 157, and there it is. That's where the query actually fired from. So we're able to deliver all that intelligence in a single payload, like I said, which is going to make it a lot easier for organizations of all sizes to figure out exactly what happened without guessing. I'll close with this final slide, which is kind of a summary of what it is that you just saw. It's effectively runtime application security. That's the space that this is. The product can be put into a monitoring mode or a protection mode. But the idea is to simplify application security and to really give people visibility into attacks that are hitting their production environment. And it doesn't matter where the apps are deployed, doesn't matter where the apps are going to. Could be in a VM, could be in a Docker container, doesn't matter. The idea is that you want security to travel wherever the application goes. And finally, we also want to be able to work at the speed of operations and development teams, which means that we have to find a way to bring security into the DevOps process. And that's something that we fundamentally believe in. So I know I'm over time, but thank you very much for your time. I really appreciate it. There's lots of interesting things that we do under the covers, including our unique methodologies. We have a booth right around the corner from here. Please come by if you have any questions. Happy to dig in. And I guess there's some fun questions already here. So let's jump in. What transaction level have you scaled the plugin to in a real production environment? So the largest one is a financial service processing millions of requests per second in a protection mode in production. So unlike a firewall, which typically runs in a monitoring mode, we're running in a protection mode, which means blocking in that particular environment. Let's see this fun one here. Do you support C#? Yes. We absolutely do. We support .NET, so that means C#, VB.NET, anything that runs on that runtime. Do you make any commitments to your customers with regard to breaches that circumvent your product? I don't think you can find many security companies that would do that. I think they would all be out of business by now if they tried to do that. Instead, what we try to say to our customers is that we're just providing a different layer of security. And there's no such thing as a bulletproof solution. You'll notice that I never once in this talk actually said that this is the only solution you need. We believe in layered support. We believe in layered protection, which means that you're still going to need some focus on endpoints, some focus on network, some focus on application security. I think if you practice that plus good hygiene, you can build a really robust security program in your environment. An overview of the licensing. Can you give us an overview of your licensing pricing model? The way it works is based on requests per second. We actually don't price based on the number of applications, the number of instances of applications, the number of users. We found that if you price based on the first two, you're actually not a modern organization, because organizations today are ephemeral with the number of instances that they fire up or the number of applications that they fire up. And doing that kind of bookkeeping is nearly impossible, and you're making it really hard for the organization to do that. So the idea is let's charge based on a request per second model, very similar to a load balancer. The idea is to work with operations teams, figure out what the load number is, and then price based on that.